we're going to talk about a thing called the Hinge theorem, which relates to the triangle inequality theorem that we've just learned about in our last lesson. And it's it's a long theorem. I'm going to read the whole thing out, and then we're going to try to break it down and make it a little bit simpler. It says, if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the side opposite the angle of the first triangle is larger than the side opposite of the angle in the second triangle. So this kind of relates to it's pretty much directly related to the side angle relationship we discussed before, where you can order sides where the smallest angle is going to be opposite the smallest side, largest angle is going to be opposite the largest side. It's this idea that if you have two pairs of congruent angles in a triangle, you have two pairs of congruent sides. In other words, these two, right? Your pairs of congruent pieces are right here, but angle A is bigger than angle D, then you know that side BC will be bigger than side EF because of the relationship between the sides and their opposite angles. So that's literally all this says. If the measure of angle A is greater than the measure of angle D, then you know that segment BC's length, or the measure of segment BC, will be bigger than the segment measure of EF. That's what the whole paragraph is summed down to, that. As long as you have the two pairs of congruent sides, then the if-then statement is true. And the converse of that is to go in the opposite direction. If you have two triangles that have congruent sides, and the side opposite of the included angle is larger on one than the side opposite of the congruent angle on the other. In other words, if the measure of BC is greater than the measure of EF in the triangles related, then you know that the measure of angle A will be greater than the measure of angle D. And so we can use this, we call it the hinge theorem. Think of like a hinge on a door. If the door is opened wider than a door next to it, the gap between the door and the door frame will be bigger on the wider open door than the smaller open door. And so we can compare the sides and angles by filling in the blanks with a greater than or less than symbol. So we're looking at JKL and NMP, and we know that we have a 9 length side and a 15 length side on each. So we've completed that two congruent sides part. And then we have the included angle, which would be N and J. That's the angle between the two sides we know about. And N is 74 degrees, and J is 79 degrees. So N, the measure of angle N, is smaller than the measure of angle J. And the side opposite N is PM, so that will be smaller than the side opposite of J, which is KL. And I only wrote it that way to make sure that I actually lined things up this way. We know KL is the bigger side, because J is the bigger angle. So if we're looking at number 2, 65 is the bigger angle. It's opposite of BC, so BC will be the bigger side. That's what that means compared to AD. That's all you need to look for. And we know this is congruent because it is one side that's in both triangles. The 24s are congruent, and these are not congruent, but they are the included angles. So now let's take a moment. We said BC was bigger. I erased it by accident. Take a moment to do the next few, 3 through 8. On number 3, we know that WX and XY are the ones we're looking for. That would be WX and XY. They're opposite of the angles that we're given, but we don't actually have the measure of angle Z. So what you'll need to do here is use the 32 and the 93 to find out that angle XZY is actually 55 degrees, which means that XY is slightly bigger, which means that WX is going to be less than XY, because 53 is less than 55. On number 4, we have these congruent marks. So that means we have one pair of congruent sides, And this middle piece is your second congruent side. And we know that we have 83 here. We aren't given anything about the other angle, except the fact that we know that it is a linear pair, which means it has to be 97 degrees. And so QP and PS are the two that we are looking at. We know that 97 is opposite of the QP, and PS is opposite the 83. So which side is bigger? PQ is bigger. So on number 5, we don't actually have any angle measures, but we do have sides related to those angles, and so we'll use those side angle relationships. Let's use some highlighting. We have 25 and 25. We have 16 and 16. So that means the 33 and the 35 are the ones that we need to use. The 33 and the 35. The 33 is opposite of the H, and the 35 is opposite of angle D, which gives us all the information we need to know. It means that angle D is going to be bigger than angle H because it's opposite of the larger side. On number 6, we're given our congruent marks. We have them marked here. And the angles are opposite of the sides we're given. So we'll say that A is opposite of your 18, and E is opposite of your 18.5. 18.5 is slightly bigger, so E will be slightly bigger than angle A. On number 7, we have the measure of angle RSQ and measure of angle TQS that we're looking for. We have a matching side here and there, and then your second matching side is right here. It's the side that is on both triangles. So we're looking to compare RSQ, which is related to the 13, to TSQ, which was related to the 14. And 13 is slightly smaller than 14, so angle RSQ will be smaller than angle TQS. Last but not least, again, we have our pair of corresponding, congruent marked sides here. The other one is the common side there. So we're looking at JMK, which is opposite of the 27, and then we're looking at LMK, which is opposite of the 28, meaning that JMK will be smaller or less than LMK. And that right there is everything on what we call the Hinge theorem. It's a very quick one, but it's a pretty important one. Thank you.